Hi everyone. In the previous class, we have seen the concept of binary codes. Like we have seen BCD code, XS3 code, like that, right? So, and also we have seen the addition of two BCD codes as well as XS3 addition. Okay, fine. Now, in today's class, we'll see another concept called error detection and error correction. Okay, fine. Guys, if you observe in the systems, the data is going to store in the form of binary format, that is in the form of 0110, or we can call it as binary format like zeros and ones. Okay, fine. If this is present in the system A and I would like to send this data to another system over the network, at the receiver end my data should be like 0110 only, right? But sometimes because of something happened, because of breakage in the linkages, because of some kind of some problem, this data may be modified and it can be received like this. It can be received like this, right? So as sender is sending 0110, receiver is getting 0111, which is actually incorrect with respect to sender, but don't know receiver don't know, and receivers think that this 0111 is also correct, right? This is what I can call it as an error, right? So error means simply a change in the sending data. I can call it as error. Because of this error, the complete result also going to be changed, right? So if you observe, it is assuming that it's a binary data, binary number system. So 0110 means its value is 6 and its value is 7, right? Even I am sending the value 6, but my receiving side I am receiving as 7. So I can call it as change in the error, right? Okay. So here, if you are able to send 0110 and you are going to get 0110, that is perfectly fine. Okay. But the question is, when there is an error, when there is an error, when I'm trying to send 0110, and if I am able to detect that there is an error in the receiving side, if I am able to detect that there is an error in the receiving side, I can call it as error detection. Means whatever data that I am trying to send, that will be sent perfectly. In the receiving end, I can able to detect there is an error. We can call it as error detection. Meaning that you can simply say that you know that where the error is, right? At the receiving side, you have known the error. At the receiving side, you know the error. See, sorry, it should be you know the error. At the receiving side, you know that the error is there. That is what I can call it as detecting the error, right? And coming to error correction, you know error is there, and you have to find out uh, where the error is there. There is a difference between these two. Okay, meaning that, see, observe, by simply looking at this particular example, when I am sending 0110, the receiving side is 0111, right? So now you simply by using some procedure identified that yes, at the receiving side there is an error. At the receiving side there is an error. That is what I can call it as error detection. Whereas coming to error correction, at the receiving side you know that error is there, as well as you identified that error is at the first bit. Error is at first bit. So if you are able to toggle this number to 0, then I can call it as actual data. So if you would like to toggle the actual bit, then you have to know the where there. That is the difference between error detection and error correction. Okay. In the reality you can able to perform error detection in many ways. Like, let us check that, right? Error detection means simply we will know that error is received, error data is received, right? So for example, if I am saying that 0 double 1 0 0 triple 1, right? This is reason. So there is an error detection. How many bits are changed here from this to this? Only one bit is changed, right? This is what I can call it as one bit error detection. One bit error, right? As there is an only one bit in change of error, I can call it as one bit error detection. Okay, fine guys. So in the reality, if I am going to have the data like this, triple zero one, triple zero one, at the receiving end, at the receiving end, if you are going to receive four zeros, how can you able to find the receiving error, receiving end, this data is error? Is it possible to find? No, it couldn't possible. If you think like I am trying to change only the second bit as it is, can you able to identify there is an error? It couldn't possible. 0 1 0 1, is there an error? Yes, of course, by simply seeing from our end we can able to, but what about system? It is not possible. 1 double 0 1, yes, there is a one bit change, that is this change, this 0 I modified it to 1, that's why I can say that there is an error. But with respect to system, how can you identify that there is an error in the receiving side? It couldn't possible, simply. Okay, fine. So okay, leave it this one. So if I give some kind of BCD system, if my transferring data system is following BCD system, I am trying to send a data called 1010. Is it possible in BCD system? I can able to change, right? Yes, its value is okay. This should be 1001. Okay, its value is 9. Yes, in BCD system 9 is valid one. Okay, at the receiving side, if I got one bit corrected, that is like if this 0 is changed to 1 and this 0 is as it is, this one is also as it is, right? At the receiving side, the data is modified or not? Yes, modified. I can able to identify it because in valid BCD system, its range is from 0 to 9 if we are going to have 4 bits. But here you got as 1101, which is beyond the range of 0 to 9. So I can say that there is an error detected. There is an error detected, right? But in BCD system, it is possible. What about in the normal processor? If even if there is one bit change, it couldn't possible to find out the error. Okay, for that, the thing is, if you are able to observe here the point, why I am easily saying that there is an error detected, because I followed certain kind of pattern. I followed certain kind of pattern. What is that pattern? The range of receiving data should be 0 to 9. 0 to 9, right? Yes. See guys, don't think about this point, right? 1 0 1 1. Again, it is also leading to more than 9 only. Okay, with respect to this bit, this is also an invalid BCD code. Okay, for example, my sending bit is like 0001. If it is modified like 0101, now it is also invalid in BCD system, right? Invalid means there is an error detected. There is an error detected. Even with respect to BCD system, it is valid, but according to this one, we can say that there is an error detected. But error detection here also it is not possible. It is also not possible. The thing here you have to understood that is there should be certain kind of pattern. If you are able to find out, then you can able to easily detect the data, right? So if I am going to have the data like 4 zeros, 4 zeros, guys, if there is certain change in these bits, obviously all those change will be comes under either 0001 or 0010 or 0100 or 1000. Any one of these four changes, see, I am trying to say out only one bit error direction. If any one of these four changes will happen, then I can say that one bit error detected. One bit. But for system, how can it do? No, right? It couldn't possible. So what I will do now, I will make the certain patterns where the next patterns is like 0011, meaning that there is 2 bit change. I have changed it to 2 bits, or I can modify it as 0110, right? I modified it to 2 levels. Okay, or I can modify it as 11 00. If you observe these two, the distance between these two is 2. Distance means what, you know, right? How many number of bits are changing? This 0 is 0 as it is, 0 is 1, this 0 is 1. What about this one? This one is also like this. Okay, so the distance between the each and every pattern is 2. The distance between each and every pattern is 2. Now, suppose that when whatever data that I am trying to send, that data contains the distance between them is 2, right? Suppose for example, if I am going to receive the data like some one bit modified, obviously it is going to be placed any one of this equation. If it is 0001, it will be comes under here. If it is 0010, it may be find here only. 0010, it may be find here only. If it is 0100, it may be find here only. If it is 1000, it may be find here only. Meaning that when you find there is a pattern, that is distance between the two valid data is 2, then whatever the data that I am trying to send, if there is 1 bit error, then automatically I can able to find that error. Okay, fine. Observe guys, if it is 0011, if it is modified to some other thing like 0 1 1 1, is it a valid data? No. Green reference valid data, red reference invalid, right? Is 0311 existed in the green pattern? No. So I can say that there is an error detected. So for example, if this error 0110 is modified to some other data 0100, is 0100 is existed between these any one of the four green colors? No. Obviously there is an error detected, meaning that when you say that distance between distance between two valid patterns distance between two valid patterns is 2, I can able to easily find out 1 bit error detection. 1 bit error detection. Similarly, if you generalize it, if the distance between if the distance between uh, something like if you take two valid patterns, if you would like to identify 2 bit error detection, 2 bit error detection, then compulsory the distance between these two should be 3 bits. I mean, if there is saying that two valid patterns are there. If you would like to find out 1 bit error detection, what is the distance between these two? Compulsory this is 1 and this is 1. So 2 bits. 2 bits. Similarly, if I am trying to say that if you would like to find out 2 bit error detection, compulsory required 3 bit distance. 3 bit distance. Okay. So if I am going to have to find out t bit error compulsory you required greater than or equal to t plus 1 distance. T plus 1 distance between the two valid patterns, then only I can able to find out the error existed or not. Okay, fine. Next one, that is error correction. Okay, so coming to error correction, once you know that where the error is, you can able to correct it easily. Right? Yes. So the thing here is, so if you would like to see, if I am going to have the data patterns like 0001, compulsory if the valid patterns are like, if you think that it is 2 bit distance, the data should be compulsory 0010 0010, right? So why I'm saying that is 2 bit distance, because there are two bits are modified, so this is 2 bit distance, right? As there is a 2 bit distance, I can able to simply define whether there is an error or not, right? Because it patterns are different. But the thing is, for example, if there is some modification between here, there is some modification, that is 0011, 0011, right? So between, I modified data like 0011 because of some problem, one bit is modified. Yes, I can say that with respect to the patterns what I am going to have available, I can say that there is an error detected. There is an error detected. Okay, see, to make it clarity, I will write once again. For 0001, what are the valid patterns? 0010 is one kind of valid pattern. What is another kind of valid pattern? 1101 is one kind of valid pattern, because I made these two change. These two are similar, and I think 0111 is one kind of valid pattern, right? Other than these four, if you got any kind of data, we can say that there is an error detected. You can error detected, right? But the point here is, if you are saying that there is an error detected, there is an error detected, but my question is here, error correction, you have to know where the error is, right? You cannot able to exactly define where the error is with respect, right? With this data you can say that there is an error, but you cannot able to say that where the uh, correction I need to do in order to make it valid data, right? So whether I need to modify this data to this bit to 0, this bit to 0, or whether I want to modify to this bit to 0, right? That is your question. That is your question. That so because of that reason, what we can do now, why I cannot able to correct here, because the distance between now the sending data and the received data is 1. The distance between some other pattern and the received data is 1. So as both are having the same length, I cannot able to justify that, right? Where the bit is modified. So this is the reason you can able to increase the distance between two valid patterns, that is 0001, and if you are able to like increase the distance between these two, right? If I am saying that, that is for example 110, I am trying to increase the distance between the two valid patterns is 3. I'm trying to increase the distance between the two valid patterns is 3. If I'm going to increase distance between two valid patterns is 3, if there is any one bit error, that will be placed here. That will place here, right? And if there is any one bit error, if you thought, that is going to be placed here. If there is one more bit changes, that is going to be available here, right? Meaning that 0000, I got this one, right? Now I got the 0 instead of 1. I can directly say that obviously this particular data, 4 zeros, is not available in my pattern. Am I right? Yes. See, if you want, you can understood. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And so on, right? If I am going to have 4 bits, actually how many patterns are possible? 16 patterns are possible. 16 patterns are possible, right? If I am going to say that this 0 is a valid pattern, 0 is a valid pattern, if you would like to detect the error, compulsory, what is the distance between the two valid patterns? If you would like to detect the error, if I would like to detect one bit error detection, compulsory the distance between the two valid patterns is 2, right? If I am saying that distance between two valid patterns is 2, compulsory for this one, what is the invalid pattern? 0010, sorry, this is 0011, 0010, and if I am going to modify third bit, it will comes under array. If I am going to modify uh, the next one, that is 1, right? Obviously if I am going to consider 0 as a valid pattern, 1, 2, 4, and 8 are invalid patterns. So if I am going to say that these 4 are invalid patterns, then only I can able to identify that there is a 1 bit error detection, right? So meaning that if I am going to have 1 as a valid pattern, obviously 0 will becomes under invalid pattern. When there is an invalid pattern, okay, fine, right? Now I identified that there is an error detected. There is an error. How can I say that error corrected? Because see, this error is detected here, right? Now I can easily say that where the error is there. So as this is nearer to this one, I can say that at the sender side itself is error is there. So I can simply modify the respective location as 1. For example, at this particular side, like if it is 0 1 1, sorry, if you got like this, now here also there is one bit error only. Here also there is one bit error only with respect to this one, right? One bit error only. But is it nearer to this one or this one? It is nearer to the receiver side, so you can able to easily correct it. Correct. Okay, fine. So here the point is, so if you would like to correct, single bit error, the distance between two valid patterns should be 3. The distance between two valid patterns is 3. If you would like to correct 2 bit error, 2 bit error, the distance between two valid patterns should be 5. Similarly, if you would like to correct 3 bit error, the distance between two valid patterns should be c. So, right? So if you simply generalize, if you would like to correct t bit error, the distance between two valid patterns is compulsory greater than or equal to 2t plus 1. This is what you can able to generalize with this example. Okay, fine. So here I made it corrected, right? I made it the correction, right? Because of this, the distance between, see, observe, see, this is 1 and this is 2 and this is 3. So 1 2. Okay, fine. So in reality, if you are able to observe this data, if you are going to have 4 bits, you are going to get 16 patterns. Out of the 16 patterns, if I am going to select one pattern, you are going to remove by 4 valid data, 4 data removed, right? Now if I am going to select 3, again you need to remove the sum of those, right? Because there should be gap of two valid pattern, there should be gap of two distance. That's the reason. So in this particular procedure, what the procedure that I have discussed up to so far, so that particular procedure cannot able to achieve at least the data from 0 to 9 itself. I cannot able to get 10 patterns, 10 patterns easily in order to accommodate 0 to 9. So that's the reason this is a difficult procedure, and that also it won't satisfy various kind of all kind of requirements. That's the reason, we'll move with another kind of error detection mechanism, that is parity bit mechanism. See, earlier procedure what I explained is also one of the procedure where we are going to identify the patterns, and then we are going to define whether there is a detected, whether there is error in the receiving side or not. We are going to detect. But the thing is, this procedure is a hectic procedure, and also we cannot able to accommodate more number of values. So that's the reason we are moving for one kind of error detection, that is parity bit. Another kind of error detection mechanism is there, checksum. Another kind of error detection mechanism is there, cyclic redundancy check. Right? These are the various kind of mechanisms that you can able to observe in the computer networks. So I will go through the parity bit mechanism in our subject, right? So guys, if you are saying that parity bit, means we are going to simply add either 0 or 1 on the data, either at the left side or at the right side, or at right side. For example, try to take the simple example, like I am trying to illustrate for you for your understandable. I am trying to take some gray code, right? 4 zeros, gray code I am going to write: 00 11 0 11 0 0 1 0 1 11 00 4 ones 1 0 1 0 1 0 Guys, if you are able to observe, the distance between two patterns is 2. Why I am saying the distance between two valid patterns is 2? Because 0 0 changes to 1. If you observe here, this 0 is changed to 1, this 1 is changed to 0. So I can call that distance between them is 2. I can call it as a gray code also, right? Okay, fine. So take out this terminology 0 1 0 1, right? Here I am trying to say that this is a parity bit. Parity bit, right? This parity bit is used for to find out error detection. To find out there is a 1 bit error, I can go for parity bit. Actually this parity bit will be comes under 2 points more. One is even parity, another one is odd parity, right? Even parity means simply it is going to count the number of ones, or the number of ones should be even. The number of one should be even, right? If I would like to make the number of one should be even in this data, what about this parity bit data? Should be 0, right? That is what I can call as even parity, right? If you would like to say an odd parity, number of one should be odd. Number of one should be odd, right? That is what I can call as odd parity, guys. So try to check. I am going to have data 100, a blank, right? Here I am trying to find out an even parity mechanism. To make this as a even parity, what is the value you have to have? Compulsory you have to have 1, so that number of 1 should be even. So this is an even parity. But assume that in the resultant side 100 is 1 guys. In the receiving side what will happen? It is going to count its number of ones, and number of ones are 2, so I can call it as this is valid data, right? For example, the same data is modified like this 1101. Now at the receiving side, what are the number of ones? 3. Then I can say that there is an error detected. Then there is an error. Guys, if you simply observe this particular example, why this is logic is perfectly correct, because when I said that to find out 1 bit error detection, how many number of distance should be there? 2, right? So observe here, so the distance between them is 2. That's why this particular logic is working. Okay, so try to think. I will take one more example. I am having a data 1001. This is at the sender side, right? Fine. Now I am trying to use a parity bit mechanism where I need to send at the receiver side. Send at the receiver. Suppose for example I need to find out the detecting the error. So I would like to use parity bit mechanism. So in parity bit mechanism, what I will do? I will simply add one parity bit either at the right side or at the left side. So and I am assuming that I am trying to follow even parity. Even parity. So if you would like to make this entire number as even parity, number of one should be even. To make the number of one should be even, I can make it as 0. Now it will be sent at the receiving side. It will be sent at the receiving side. At the receiving side, I got this one is modified to 0. This is 0, 0, 1, 0, 1, 0. Now at the receiving side, what it will do? It will follow the same approach, even parity approach, right? Our number of ones should be again uneven, but number of ones are even, so it can say that there is an error detected. There is an error detected. Okay, fine. That's the thing is going to happen in the parity bit, right? See, not only I can able to add at the right side, you can able to add at the left side also. 1001. At the left side also you can able to add. So you can able to add at your wish. But simple thing is the you have to add depending upon what you want, whether you want to have number of ones as even or number of ones as even odd, right? So this is the thing you have to follow. But the problem in this particular approach is, if the sender is sending 10010, receiver modified 2 bits, like this 1 is modified to 0, this 0 is modified to 1, and remaining data is as it is. Now what will happen? It will simply find out whether it is even parity or not. Yes, it is even parity, so it will think that there is no error, and it will thought that it is a correct data. That is a problem what we are going to have in the parity bit mechanism. Parity bit mechanism, right? So parity bit is a kind of 1 bit error detection mechanism. right? If there is more than one bit changes, then this particular method is not going to work for you. Okay, coming to checksum. Okay, so these are going to be discussed in the computer networks. Okay, for time being, I will just let you know what is the meaning of checksum. Try to observe the meaning of checksum is, so the name itself is clearly providing. It is going to check its sum. Okay, fine. So if you observe here, uh, in checksum procedure, we have a valid data. We have a valid data. 1 minute. Hmm. We have a valid data. Assume that the valid data is 1 0 1 0 1 double 0 1 double 0 triple 1 double 0 1. This is the valid data, right? If you observe here, this is 8 bits and this is 8 bits. Okay. In checksum mechanism, whatever data that you are trying to send, that will be split into n blocks. That will be split into n blocks. Then I am going to perform its sum, right? For example, I am trying to make it as 8 bits as one block. Then I will get 1 0 1 0 1 double 0 1 double 0 triple 1 double 0 1. I am going to make it performance operation, sum operation, right? If I am going to sum its operation, you will get here 1 0 0 1 0 1 0 1 1 1 1. Right? This is what I am saying, that sum, right? So initially the sending data should be split into n blocks and I am going to perform its sum. Then after this step, you have to make its complement. You have to make its complement, right? What is the complement of this one? The complement of this particular procedure is triple 0 triple 1 0, right? This is what my checksum now. My checksum. Okay. In the receiving side, okay. So how we are going to send the data now? You are going to send the data in the form of data followed by checksum. Followed by checksum. What is the data you are trying to send? 1 0 1 0 1 triple 0 1 double 0 triple 1 double 0 1, and checksum is what? Triple 0 triple 1 0 1. This is the data you are trying to send. This entire data you are going to send at the receiving side. Now at the receiving side, it has to check whether this received data is correct or not. Then what it is going to do, as in checksum procedure, it is going to split into chunks, or it is going to split into n blocks, right? So again 8 part, right? 1 0 1 0 1 double 0 1 as one block, I think 8. Okay. Now double 0 triple 1 double 0 is 1, is this one s1 s2, and this is check 3, right? Checksum, right? Checksum is what? Triple 0 triple 0 triple 1 0, and then now we need to perform its sum. Its sum, right? If you are going to perform its sum, you are going to get triple 1 is 1 1, this is 1, this is 1, this is 1 1, this is 1 1 1 1 1 1, right? You got the sum, right? For this sum, what you have to do again? You have to make a complement. If you are going to complement it, you are going to get all zeros. When you are going to get all the zeros at the receiving side after the completion of process, then I can say that there is no error. There is no error when the result is 0. When the result is 0. Sometimes result may not be 0. Result may be some positive value. At the same, we can say that there is an error detected. So checksum is a procedure where we are going to follow for the whether there is an error or not. That's it. Right? Okay. Fine. Fine, guys. But here also there is some problem. There is a drawback. What is that, guys? Can you able to get, if I am going to modify this data with the checksum data? So finally, if you are going to add, Can you able to get all ones so that its complement will be 0 again? Yes, obviously it is possible. So that is a drawback of checksum. For example, if you take the same data only, the same data 10 10 1001 01 00 triple one triple one 001 001, but at the receiving side, my data will look like this. My data will look like this. Instead of sending this entire data, there are few minor modifications happen. Assuming that, okay. So if there are few minor modifications, if I am thinking, so those few minor modifications are like, for example, this one is changed to 0 0 0 1 0 1 0 1 1, and this one assume that change it to 1 0 triple 1 001, and this data is as well triple 0 triple 1 0. Okay, meaning that this data is changed and this data is changed. Okay. At this point of time, so this one should be 0 and this one should be 1. This one should be 1, and the receiving data is as usual. So I can rightly write like triple 0 triple 0 triple 1 0. Now try to add. You are going to get 1 1 1 1 1 1 1 1 1 1 1 1. Right? You got the number all ones, right? If I am going to perform complement operation, again your result is going to be all 8 zeros. Triple 0 triple 0 0 0, all 8 0. So result is 0. Can we say that there is a no error? No, there is an error. There is an error, right? That is a drawback of checks. Right? So next we'll go with the cyclic redundancy, all those things you can check in the computer network subject, right? So these are the three major methods that we are going to follow whether there is an error detected or not, right? But the thing is, so as these are all methods having various kind of problems, we'll go with one kind of method where we can able to detect the error easily. That is Hamming codes. This is very important. Hamming codes. Okay. See what we did so far. We are going to have m data bits, and those m data bits you are going to send it to other side, meaning that I am trying to send it from the sender, and at the receiver side I am going to receive m bits only, but there is a small change in these bits, like it can be 1 bit error or 2 bit error or some kind of maximum of m bit error also possible, right? So because reason, the initially we discussed the basic approach. In basic approach we can able to detect the error, but the problem here is it is very hectic process, and we cannot able to more data more data, right? So this is the reason we are moving for parity bits. In parity bits, the problem is if more than one bit is changed, or some even number of even number of bits are changed, then this procedure won't work for you, right? So observe this one, as this bit is changed and this bit is also changed, there is no error it is saying, but actually there is an error. That's the thing, right? If the number of bits are changed by more than one bit, then the parity bit won't work for you. Similarly, in checksum also, as bits are changed, compulsory your result may be get all zeros when you are going to complement in the receiving side, but that is also invalid procedure, right? So the to overcome these things, To overcome all these things, we are moving for Hamming codes. In Hamming codes, we can able to detect the error. We can able to detect the error. At the same time, we can able to correct the error. That is the advantage of Hamming codes. Advantage of Hamming codes. Okay, but here you have to follow certain procedure where that procedure is very simple. See, I am trying to send m data bits. For this m data bits, I need to send p parity bits. P parity bits. That's it. If you are going to do this, then you will solve the problem of that error detection as well as error correction. How it will happen? Try to think. See, if I am going to send m data bits, p parity bits, in how many bits the data may be changed? M plus p bits data may be changed, right? So as I am saying that, if I am saying that m bits are data bits are sent, 1 bit, 2 bit or m bits are going to be changed, right? If I am going to send m plus p bits, m plus p bits data is going to be changed, or there is no change in the error. So this one represents there is no change in the data, right? So m plus p means what? These are the many number of errors occur. Many number of errors occur. Okay, fine. So the procedure will look like this. So when you are going to do some kind of parity mechanism, first thing is you have to write down the message bits as well as parity bits. How we are going to do now? So you have to take P1, P2, D3, P4. Sorry, it should be D3 only. It should be P4 and D5, D6, D7. Don't think about any new. Here I would like to simply say where I am saying that it is parity. Parity means it is powers of 2. 2 power 0 is 1. 2 power 1 is 2. This is 2 square and this is 2 cube. Right? 2 cube is 8, right? P8 is the parity bit. Right? Like this you have to set your data, right? So meaning that if I am going to have m data bits, how many parity bits are required? For example, if I am going to have the data, 1011, I need to send 1011 data to other side, from sender to receiving side. How many parity bits are required for me according to this particular pattern? Try to fill the data, right? Don't think about the parity. Here you need to fill 1011, right? From the right side you are going to fill. So D3 as 1, D5 as 1, D6 as 0, D7 as 1. Do we require P8? No, no need. Meaning that in order to represent m data bits, you require p parity bits. What does the p represents? P represents the powers of 2. Powers of 2. Try to think. See, if I am going to have 5 data bits, 5 data bits, uh, 5 data bits, how many parity bits are required? Right? If I am going to have 5 data bits, what are the D9 represents? Here I have to accommodate. If I am going to accommodate, compulsory required one more parity, right? So if I am going to have 4 message bits, you require 3 parity bits. If I am going to have 5 message bits, you require to have compulsory 4 parity bits. Like this, you need to find the relation, right? Is there a relation between these two? We can define as 2 power p greater than or equal to m plus p plus 1. This is the relation that you need to define the to answer the number of parity bits are required, right? If you are going to simply observe 2 power 4 is greater than or equal to this one, 2 power 5 is greater than or equal to this one, like that. Okay, fine. See, I am saying that here, if you would like to represent m data bits in the Hamming code representation, compulsory you required the value has to satisfy this particular property. This many parity bits are required. Okay, fine. Guys, as I said, like 1011 assume that is my data wants to transfer. How we are going to represent? You are going to represent parity 1, parity 2, D3, P4 because it is 2 power 2. D5, data bit 5, data bit 6, I think data bit 7, right? So 1, 0, 1, 0. So what does this parity bit defines? So this is the heart of the concept. Parity bit defines. So there is one pattern which is following. We can able to follow. I said whether it is an even parity or odd parity. Assuming that for time being, I am trying to follow as even parity. Even parity, right? P1 value defines. P1 value defines P1 comma P1 comma. You have to left out one location. Then you have to include D3 and you have to left out one location, then D5, then you have to left out one location, then it is D7, right? Now what is the value of P1? Don't know. What is the value of D3? 0. What is the value of D5? 1. What is the value of D7? 1. 1. Now to make the P1 value as even parity, what is the value you have to place here? That should be 0 because two ones are already there. So P1 value is 0. P1 value is 0, right? Now to find out the P2, you have to write two consecutive terms P2 comma D3, P2 comma D3, and you have to left out two terms and you have to write the next two terminology D6 comma D7. What is P2? Don't know. What is D3? 0. D6 is 0. D7 is 1. Right? To make this as even parity, P2 also even parity, what you have to do? You have to add 1 here. So 1 I have added. Okay. Now to find out P4, you have to consider consecutively 4 terms. Consecutively 4 terms. If there are any other terms are there, 4 terms we have to be not considered, then we have to consider 4 terms, right? So P4 value, if you are going to find out, P4 comma D5 comma D6 comma D7, D7, right? So what is P4? Don't know. D5 is 1, D6 is 0, D7 is 1. Now to make this as even parity, what will I have to place here? 0. So I have to place here 0. So this is my the data I want to send from sender side to receiver side. So at the receiving end, my data will look like 1 0, 1 double 0, 1 1 0. Now what the receiver will do? Receiver will first check for error exist or not. If there exists an error, then it will able to find out the correction. First, let us check whether there is an error or not. Right? So how can you do that? So for that, I will do a simple modification in this receiving side. See, at the receiving side, I am trying to say that I received in place of 1 as 0. In place of 1 as 0. At that time, obviously, you know, right? So there is an error detection, right? How can I do that? Right? So the thing here is try to find out again the relation. This is P1, P2, D3, P4, D5, D6 and D7, right? Now try to find out the value of P1. What is the value of P1? Value of P1 is again P1, D3, D5, D7, right? So you have to take 0, this 0. See, I will write again in blue colors, right? This I have to consider, and D3 I have to consider, D5 I have to consider, D7 I have to consider, right? 0 0 0 1, 0 1, right? 0001. Guys, with this example, can I say that P1 contains an even parity, but I got as odd parity. I got as odd parity. So I can say that error is detected. I can say that error is detected. Okay. So with this example, I can say that error detected happened. Okay, fine. Now try to check out for P2. To find out the P2, you have to consider P2 D3, and then you have to remove the not consider 2, and then you have to consider these two, right? So you will get 1 0 0 1. So even parity, there is no problem. So there is no error. There is no error. At the it thought that there is no problem for P2. What about P4? You have to consider contiguously 4, that is 0 0 0 1. 0 0 1, and it thought that it got an odd parity, it got an even parity. So my point here is, as I am following the even parity approach, at 21 of the parity bit side, if I got odd parity, I can say that error is detected. What about the error correction? How can correct where, so it has to identify whether this is correctly there is error at this side. Try to think, right? So guys, observe, I will try to write some particular logic here. At the P1 side, I am going to make 1. At the P2 side, I am going to make 0. At the P4 side, I am going to make 1. What is this 101 value? 5. What does the D5 means? Meaning that this 101 defines the error location. The error location. As the data here received as 1, I can able to modify it as 0. So now this is my correct data. How you got this one? Okay. Sometimes you may get like 100, right? Then what will happen? See, you have to write like this. So at the checking side, at the checking side, so you have to think as, you have to arrange the data in such a way that P4, P2, P1, right? As this is a kind of a palindrome 101, or in any order if you call it as 101, so there is no problem. Sometimes you may get 100. At the time you have to question, right, whether it is 100 or 001. So the reason, the point you have to do is, you have to make them arrange in the form of P4, P2, P1, P2, P1, and this I will technically call it as C1, C2, C3. Technical call it as C1, C2, C3. Then this is my data. So 101 is the location where I got error. See guys, what does this 1 means? What does this 1 means? What does this 0 means? So this 0 means there is, it is already even parity. This 1 means odd parity. This one also means odd parity. Odd parity. Guys, if you observe here, P4 represents what? C1, P2 represents C2, P1 represents C3, right? C1 and C3, C1 and C3 means intersection of, so when both are ones, I can say that intersection of C1 and C3. What is the intersection of C1 and C3? Intersection of C1 and C3 is, common things are D5 and D7. D5 and D7. And what is this C20 means? I am going to subtract from C2, right? D5, D7, I need to remove it from this P2, right? If I am going to set different D5, D7, P2, D3, D6, D7, what you are going to get? You are going to get the data which is not present in the second set, that is D5. That is what you got, right? So this is the way you can able to correct the error. I hope you understood clearly, right? So for your simplicity or for your understandability, I will take one more example with direct explanation. For example, I would like to transfer uh, a 4-bit data, or I think in the earlier I have taken 4-bit only. Now I will take some 4-bit. Okay, so because if I take 5 bits, it will be long. So 000 1. 0001, this is my message data I am trying to send, right? So for this 0001 data, I need to add parity bits. Parity bits are in the form of P1, P2, D3, P4, D5, D6 and D7. So my data will look like 0001, and I need to find out the parity P1. P1 value means what? It is a combination of P1. I need to left with 1, that is 1. Sorry. I have to write separate if for your understandability. So this is empty 1, empty 0 and empty 0. So to make this as even parity, I have to make this as 1. This is for P1. What about P2? I have to consider these two, that is empty comma 1, and I have to left these two, and I have to consider these two, that is 0 comma 0. So to make this as even parity, I have to consider here also 1. Next, to find out the P4, I have to consider all these 4. So to make even parity, I have to compulsory make it as 0. This is data, right? Now at the receiving end, I received this data perfectly, and it is going to calculate C1, C2, C3, and as there is no error, there is no problem. So obviously nothing happened. But if you thought that there is an error change, there is something change, right? For example, 0 1 0 1 0 0 1 1 1. Guys, if you are able to observe here, I modified how many bits? I modified only one bit. So meaning that this Hamming code procedure is one works for one bit error correction, not for many bits. Okay. So now try to calculate again P1, P2, D3, P4, D5, D6. So it should be D6, it should be D7, right? So now if I calculate the P1 value, P1 is 1 comma 1 comma 0 comma 0, 0 comma 0. So I got even parity. So there is no problem. If I calculate P2 1 1 1 0, right? So P2 means these two and these two, right? Now I got odd parity. Obviously I can say that as odd parity got, so I can say that error is detected. Error is detected. Now I will calculate P3. Sorry, it should be P4. P4 means combination of all these 0 1 double 0. So as I got again odd parity, I can say that error is detected. But the question is where the error is. Where the error is. So that is what I can call it as error correction. To make do that, so what you can do, you can make as check bits C1, C2, C3. What are these check bits? Those will get from P4, P2, P1, right? What does the value of C1? If there is an odd parity in P4, I can say that this is 1. So there is P2 also odd parity, so it is 1, and P1 is an even parity, so it is 0. So what is the meaning of this 1? 1 means the bit is modified for the P4 value. The P2 means this one. So what is the meaning of 110? 110 value is 6. 6. If you calculate the bit number 6, so bit number 6 is modified. So if you are able to modify the toggle the one with the another value, that is 0. So your result will be 000 0 triple. This is your answer. So this is the way you can able to use Hamming code procedure to find error detection or not existed. If error is there, then you need to rectify that error. We can call it as error correction. I hope you understood clearly. Thank you.